Okay, good day, grade 10. How are you guys doing today? We're going to be looking at lesson number 6 on the topic covalent bonding. Covalent bonding. Right, so this is a concept which we did in grade 8, talked about it again in grade 9, but now we're going to do it again in grade 10, and you will find that there is going to be a lot of new stuff. There's going to be a lot of new material that we're going to add onto it. So I want you, as always, to approach this with an open mind, right? And be very willing to learn something new. So our objectives for today's lesson will be, as stated here, to describe the formation of single covalent bonds, describe the electron arrangement in complex covalent molecules. That is what I think will also be very different about this topic, the way we'll be covering it now in grade 10. That we will now be looking at complex covalent molecules. Remember when we were in grade 8, we looked at one for, the ones for hydrogen, the ones for water, but now we're going to look at the one for nitrogen, which has a triple bond. We're going to look at one for, even for an alcohol, right, ethanol. We're going to look at one for ethanol or for methanol or for different types of alcohols, right, and even alkenes, such as alkene, as in alkane. We have alkanes, then we have alkenes, okay, and then we're going to look at one maybe for ethene or propene, depending. By the end of this lesson, right, we'll be able to then draw those different covalent molecules using the Lewis Cooper notation. Okay, right. So just take a few seconds to just look at the objectives again. So you just pause and you just try to look at those formulas, those symbols to say these ones, these two. I hope they're showing properly. C2H4, CH3, OH, and just get a hang of those. Okay, so at the beginning of this topic, we will again talk about why bonding takes place in molecules, in atoms. Why do atoms take part in bonding to then form molecules and to then form compounds? You will find that from our base definition, from way back when we were in grade 8, and we've been talking about this concept, we have talked about it several times. Atoms react so they can obtain full outer shells, right? So we have atoms that we'll find that are in group 1, or atoms that will be in group 7, group 6, and depending on which group that atom is found in, that atom will either want to gain some electrons. Let's say in the case of oxygen, which has 6 electrons in the outermost shell, it will want to gain 2 electrons so that it can form, or it can have 8 electrons in its outer shell. And then when it has these 8 electrons in the outer shell, we say it has a stable outer shell, a full outer shell. So we know that that is the objective of these atoms when they take part in, when they bond, and when they take part in chemical reactions. Then in the previous lessons we introduced this concept of electronegativity. So I hope that we still remember what electronegativity is. The definition is given here. Refers to an atom's ability to attract electrons towards itself. So when an atom is going to take part in a chemical reaction, it will want to attract electrons towards itself, right? And then there will be the sharing of electrons. But when they are being shared, they can only be shared because there is a positive center that is pulling the electrons from the other atom. Even if it's hydrogen and hydrogen, right? The nucleus of the first hydrogen is pulling the other electron from the other hydrogen if we are having that H2 molecule. So as I'm explaining these things, if you are a chemistry student, by now you must have an idea. The moment I just say hydrogen, H2, those two orbitals, right, those two atoms of hydrogen should just pop up into your head. You should just see them, and you should just see their outer shells overlapping, right? So when they're overlapping, there's an electron from the first hydrogen and an electron from the other hydrogen, and they're being pulled towards each of the positive centers, and that is how the bond is formed. And that's where the aspect of electronegativity comes in, an atom's ability to attract electrons towards itself. So we'll remember that now with covalent bonding, okay, in covalent bonding, there is a sharing of electrons. There is a sharing of electrons, as opposed to, what is it called? As opposed to ionic bonding, where ionic bonding, you have the metal donating an electron and the non-metal accepting an electron, right? And this is just the slight difference between ionic bonding and covalent bonding. So you guys can just look at the definition of a covalent bond. This is what it looks like now at this level. Right, so if you observe now with the definition of the covalent bond at this level, they now bring in the idea of an electrostatic force of attraction. Electrostatic force of attraction that holds together nuclei sharing electrons between them. Okay, so these are the nucleus of the two atoms that would have covalently bonded. And how does an electrostatic force of attraction come in? It comes in because we have a positive center. The nucleus, remember, it is positive, and they are pulling towards themselves these negatively charged electrons. And moment you have this positive and negative being pulled together, that's where you have this electrostatic force of attraction. And that's what a covalent bond is, basically. Okay, right. So at this level now, my main concern in this lesson is for us to understand that we then have different types of covalent bonds. Okay, so we just knew that, okay, we have covalent bonds when hydrogen bonds with oxygen, the ratio of 2:1, 2 hydrogens to 1 oxygen, that gives you H2O, and that is water. Right now we are looking on the, let me just highlight it, that one, the one that I've just highlighted, that is methane, Ch4, right? That is methane, and it says here 1 pair of electrons being shared. There is 1 pair of electrons being shared there, and there, right? There are 4 hydrogens bonded to the carbon, which means that there are effectively 4 single covalent bonds there. When I will explain the part of, let me just go on then and then show you this one for oxygen, so that I can explain what the difference between a single covalent bond and a double covalent bond is, because I think that's where the main issue is for this lesson. So if you read double covalent bond, right, I really hope that when I'm touching this thing, it's also showing where I'm touching, because that's the whole idea. I want where you see a dot, that's where I'll basically be referring to or directing you towards. Okay, so double covalent bond between atoms sharing two pairs of electrons. Okay, I think I left out a word there. 2 pairs of electrons, 2 pairs of electrons being shared. Here, with the methane, 1 pair of electrons is being shared. I know you guys will probably start getting confused to say, what about, but it seems like there are 4 pairs. No, they are not 4 pairs. That hydrogen, that's 1 pair, the hydrogen and the carbon. That hydrogen with the carbon, again, it's a single pair, right? So these are single covalent bonds. 2 electrons are being shared. Now, if we have a double covalent bond, then you will find that there will be in this overlap, right? Let me highlight this one, or let me highlight what I want is to be touching in the center. I want to be touching in the center where there's a red dot, blue cross, red dot, blue cross. Those 4 electrons that are being shared by these 2 oxygen molecules basically represent a double bond. They represent a double bond. So if you were to, I want to see if there is something, let me just quickly scroll down. Alright, let me just quickly scroll down and see if I can find, maybe it's in the next document. Right, if you were to draw it, okay, if you were to draw it, you will find that you draw, let me pause this just for a bit. Okay, so if you are looking now at the diagram that's on the screen, that's carbon dioxide, and the carbon atom and the oxygen atom are reacting, and we have 1, 2, 3, 4, and 1, 2, 3, 4. If we're looking at the molecule of carbon dioxide, it has 2 double bonds. And what I was looking for when I paused this video was so that you could see that when you then write it as carbon dioxide, it has C in the middle, and then there are 2 lines. Those lines are bonds. It's not an equal sign. It's not saying O is equal to C is equal to O. No. Those are bonds. Right? And because there are 2 lines there, it means that it's a double bond. It is a double bond. So carbon and oxygen, CO2, you have 2 double bonds that are there. Right? So remember, what is our main concept that we are looking at? We are looking at this concept where we're saying we have single covalent bonds and we have double covalent bonds. So I'm happy that I was actually able to find this one, which is even in a way more descriptive. Is even what? In a way more descriptive. So if you look at this one now, this is the molecule of ethene. The molecule of ethene, this is also a covalent molecule. But these are complex covalent molecules now. So if you see that you have C2H4, C2H4, that's ethene, right? That's an alkene. It is a double bond. So the 4 electrons that are being shared between the 2 carbons, those ones give you the double bond. Then the hydrogens that are bonded to the 2 carbons, they have single bonds. So you will find that in the same compound, you have single covalent bonds, 1, 2, 3, 4, single covalent bonds, and then you have 1 double covalent bond. And if you are drawing it, right, if you are drawing the structure, this is a very simple structure. This is the simplest thing you can draw, right? It's a carbon which has a double bond to the other carbon. Right, so when we're still there, let's also observe that each of these atoms, hydrogen, hydrogen, carbon, carbon, hydrogen, hydrogen, all of them have now attained a full outer shell. All of them have now attained a full outer shell. Okay? And I can see that at this point, why did I even move it? Right, there. What is a covalent compound? Give 5 examples. Right, so that can be your homework also. That can be your homework for those who like always asking to say, what is our homework? What is our homework? That will be your homework for this week, right? Just answer all the 5 questions, right? Or you can answer up to number 4. Yes, answer up to number 4. Number 5, I'll explain that one in the next lesson. I'll explain that one in the next lesson, right? So going back to this one, so that's a double covalent bond. But we also have what we call triple covalent bonds. Bonds between atoms sharing 3 pairs of electrons. 3 pairs of electrons. So when you look at the example that we have there is of the nitrogen molecule. It's of the nitrogen molecule. There is a triple bond in this nitrogen molecule. Triple bond. Because they are sharing how many? They are sharing 3 pairs of electrons. 3 pairs means 3 times 2. So if you see that there are 6 electrons that are being shared, then you know that that is actually a triple bond. Let me see if there is no nitrogen molecule that was drawn, which is a bit bigger. This one. So triple covalent bond in nitrogen. So if you were to look at it, this one, you will find that there is a dot, cross, dot, cross, dot, cross, and if you count them, there are 6. Then if you count the number of electrons that are now in this nitrogen, the one on the left and the one on the right, if you count all the electrons, they should always add up to 8. The electrons that you have between your molecules which are sharing electrons, they should always add up to 8 to show you that what they have attained the full outer shell which they want. Right? So now this one on this page, we can see that is now water, and they are single covalent bonds. Right? Those are examples of single covalent bonds because only 2 electrons are being shared. If you look at water here, the blue cross and the red dot. Blue cross, red dot. Right? They are representing single covalent bonds. In hydrogen again, single covalent bond. In chlorine, single covalent bond. In ethane. Right, so this is now a complex covalent bond. But even though it's complex, it still has single covalent bonds only. It still has single covalent bonds only because between the hydrogen and the carbon is just 2 electrons being shared. 2 electrons being shared, right? So I'm just going to show you basically all of the different single covalent bonds and double covalent bonds that I have on this PDF. But what I want you to do is to then draw them yourself and then get to count and see why exactly have they been drawn like this. I remember when you guys were drawing one for carbon dioxide when we were in grade 9, and you just ended up just putting in crosses and dots and not knowing why you were putting in those crosses and those dots. But you should remember that oxygen wants to have 8 electrons in its outer shell, so does carbon, so does the other oxygen. So when you count them, when you have all your electrons now having been shared, that is what you should get in the end, right? So that's now the level that we are now at for covalent bonding. Draw a diagram to describe the covalent bonding and the arrangement of ethanol. That's also added. It will become the number 5 to those first 4 questions that I showed you in the other PDF. This one, right? I said question number 1, number 2, number 3, number 4. Then number 5 won't be from this one, it will be from here. This one will effectively be your number 5, right? I will tell you in the group when you should submit it, but do not rush. Do not rush. I will explain the concept, we'll discuss the concept. So let's just take a look again. Let's just go back to the top and conclude this lesson. That is basically it about this lesson, right? So as a chemistry student, you know what covalent bonding is. You know what ionic bonding is, but today we have been looking at covalent bonding, right? And remember, there is no formation of cations or anions here, right? Because no electrons are being donated, they are being shared. And when you share electrons, you form molecules. So we don't have cations or anions. None of these are cations or anions, they are all molecules. So you now know, you are now able to describe the formation of single covalent bonds, double covalent bonds, and triple covalent bonds. Right? Don't ask me please about quadruple covalent bonds. Right? Don't ask me about those ones. Right. So grade 10s, I hope you watch the video, draw the diagrams. Thank you very much. This is Marshall A.C. Candiado.